Warm welcome to all who are attending our raw materials session on the good practices. I'm with me Susha. We are coming from the regional center, Adria EIT Raw Materials Hub, and we are hosts for this session. And we will go through several projects which were run by the EIT Raw Materials umbrella, starting initially with the, let's say, overview presented by Tina Benda, our EIT Raw Materials Risk Manager. So please, Tina.
Hello and greetings to all. Thank you for having me here today. My name is Tina Benda. I'm a geologist. I'm based in Ljubljana, and I work as the Regional Innovation Scheme Manager or Risk Manager at EIT Raw Materials KIC or community. And today I will tell you more about the EIT Raw Materials programs for business creation and support, innovation projects and education, and the opportunities for the Slovenian ecosystem that lie within the activities of EIT Raw Materials. So you have heard from my colleague today about the raw materials topic, and I would just like to emphasize again that the EIT Raw Materials is supporting innovation teams throughout the whole value chain of raw materials. What does this mean? So we support innovation from exploration, mining, processing, but also recycling and circular economy activities and substitution of critical and toxic materials. And even more focus is presented in our so-called lighthouse programs. You know, most of our activities revolve around metals and minerals, but especially on metals and minerals for strategic technologies and value chains, such as batteries, fuel cells, magnets and motors, photovoltaics, electronics, and lightweight design. And here on the top, you can see these are the three lighthouses. They're called responsible sourcing, sustainable materials, and circular societies. And these are the main thematic focus areas of EIT Raw Materials. So smart, data-driven targeting of ore deposits, mining and ore processing at highest safety and environmental standards, increasing the social license to operate, and decarbonization are the topics under responsible sourcing. Under sustainable materials, we have the substitution and also resource efficient materials design. And in circular societies, lighthouses, the activity should focus on industrial symbiosis, end-of-life product recycling, design for recycling and lifetime extension, but also traceability and sustainability of the supply chain and its transparency. So these are even more focused thematics that the EIT Raw Materials support. We have several activities, but today I will present you the ones who are most relevant, I would say, for all of you listening to the event today. And the first activity that we offer is matchmaking and networking. For instance, we organize the Raw Materials Summit Conference. It is a global annual conference which includes technical sessions, but also investors forum, career fair and trade show. And it's one of the biggest raw materials events in the world. And you can also, the next one will happen in May next year, and you're all kindly invited to come there, meet our partners, and meet all other actors of the raw materials sector. We also have a lively alumni community, which brings together everyone who has ever worked on an EIT Raw Materials activity, so that they can stay connected, and it offers networking, careers, and mentoring opportunities. So this is one, matchmaking and networking. There are also many more events for our partners. So if you're interested in that, you can always ask us some questions about that. The other activities are innovation support activities. And as you can see here, they go from the very beginning, from the idea holders, and all the way, to the higher TRL levels and industrialization. So I will present each step in a bit more details, but we are supporting TRLs from 1 to 3 with the Jumpstarter program, TRLs above 4 with the EIT Raw Materials Accelerator and Booster. And then for solutions who are above TRL 5, there are the upscaling projects, which are selected through an open call that is opened once or twice per year. And last but not least, for the very high TRL levels, there is ERMA. ERMA stands for European Raw Materials Alliance. And this alliance is coordinated by EIT Raw Materials, so by us. We were mandated by the European Commission to lead the alliance, and any raw materials related projects can be submitted on the European Raw Materials Alliance website, and you can check it out. And if you would like to ask more questions about ERMA, please let me know. But now let's go to this lower TRLs, to innovation and acceleration, to the early phase. The Jumpstarter program has a call opened every year, usually around March or April. And this is for young innovators, or, well, it can be for any innovator who would like to learn the basic of entrepreneurship and just test if their idea is good enough to become a potential startup. This is an 8-month program with workshops and coaching. And like I said, it starts in April and then ends in December each year. And this is for TRLs from 1 to 3. The next activity that we offer is the Startup Accelerator. This is for early phase startups who want to build a company. This is a 21-month program. It has 3 phases with workshops, expert coaching, and also with funding available. There are 2 calls per year for phase 1 for the Startup Accelerator, and you have more information, of course, on the website. And then for more established startups and SMEs from the raw materials sector who want to speed up their market introduction, there's the Startup and SME Booster of EIT Raw Materials. This is a 1-year program, and it offers business support and targeted funding. There is a call open every year, all year, and there are 3 cutoff dates at which the applicants are selected and are then entering the program. So this is for Jumpstarter for very low TRLs for idea holders, the Startup Accelerator for early phase startups, and then the Booster is for more established startups and also SMEs who want to reach the market faster. And then the next stage of innovation support that we offer are the upscaling CAVA projects. The call for upscaling projects is open once or twice per year, and this is for the project who want to raise the TRL level of their solution and then enter the market. So this is for TRLs of minimum of 5. There are 1 to 2 calls per year, and these are usually 2 to 3 year-long projects, and we offer business support and funding. There is also co-funding mandatory for these projects, and the backflow mechanism needs to be integrated. This is a 2-stage application process. So first you submit a draft proposal for the upscaling call, which is a 5-pager, and then only if selected in the first stage, the whole proposal with a very detailed budget, activities, milestones, and so forth is prepared and submitted. And you can see more, or I should rather say the CAVA Call 11 is coming out around November 21st, so you can see for yourself what is the content of the call. So now we've seen the matchmaking activities and the innovation and business creation support activities that we offer, but we also support the educational activities. So also at late November, there will be an open call for higher education activities or projects, and also for lifelong learning courses. So you can also apply with educational projects to our next call. For instance, through these calls, our master programs were selected. These are all led by the EIT Raw Materials partners or consortia, and most of them are high mobility programs. So each semester, you see here the topics of the master programs, and each semester the students travel from one to the other university, have a lot of site visits, and most of these master programs also provide a scholarship for the students who apply to them. And all the students are very welcome to apply to any of these master programs. All the alumni of the programs are really excited always of all, the travel that they make and the knowledge that they gain. And of course, all the master programs are raw materials related, like Master in Resources Engineering, Sustainable Materials, there's one on exploration, and then Materials for Innovation and Sustainability, in Materials Recycling, and then Innovative Natural Resource Management, and so forth. So everyone is very welcome to apply. Okay, so these were the education programs. We do also support the wider society learning activities. This is just a few examples. We would like to make sure that more and more girls study geosciences and geoengineering to improve the gender balance in the sector. So this is why we support the ENGI project, and also the Raw Materials at Schools is a project that is promoting careers in the raw materials sector. They created a toolkit, and it's a very, very large consortium of 30 organizations in 20 countries, and they are showing to the pupils from the ages 10 to 19 how great it is to work in the raw materials sector. This is also an interesting initiative for the higher education institutions. This is the HEI initiative. It's a capacity building program for higher education institutions. So the EIT and all the KICs established this initiative. The third call is coming out now in November, soon, and you can check on the website for more details. So what is the initiative about? It is actually a call for proposals, consortia of higher education institutions, but also other entities apply together to strengthen the entrepreneurial and innovation capacity of the universities. So how to make sure that their programs are more entrepreneurial and that they really include this innovative approach into their teaching system. In the calls 1 and 2, 49 such projects were selected and are now being implemented, so the budget is quite high. The project lasts for 2 years, and the project budget can be around 1,200,000 euro. So welcome to visit the page, and there will be also webinars soon after November 15th. Anyway, this is towards the end of my presentation. It's quite a lot, but I would say that there are 3 main segments. So one is the matchmaking. We have 300 partners, part of our community. They are all from the raw materials sector. The big players and the small players can connect through our events, and this is a great opportunity to talk to some of the big players that are, sometimes or otherwise hard to reach. And then also all the calls for projects or the business creation and support activities to support startups and SMEs. We would be thrilled to have more Slovenian companies entering our program. In case you have any questions or you have ideas and you would like to see if this is in the scope of EIT Raw Materials, or how the idea should be formed and what are the due dates, please do contact me. Here you have my email address, my colleague's email address. You also find us online. We are the Innovation Hub East of EIT Raw Materials that also covers Slovenia. And I would like to thank you for your attention and wish you a very nice rest of the day. Thank you very much.
Thanks to Tina. And now we are going to continue with the presentations of good practices supported by our KIC, EIT Raw Materials. We have here with us today 4 speakers. And the first, I'm inviting Professor Tina Žužek, who is the leader of the group for magnetic materials of the Department for Nanostructures Materials at Josef Stefan Institute. She has more than 20 years of experience working in rare earth permanent magnets, and she's involved in several national and EU research-funded projects. Tina, I'm inviting you to start your presentation now.
Thank you very much for your kind introduction and invitation to this vivid event. I'm flattered to and honored to present our project, which was funded in the frame of EIT Raw Materials in the scheme of regional innovation funding. So the idea behind is trying to boost the magnetic properties of the permanent magnets, focusing on the factories still remaining in European Union that still produce the permanent magnets. There have been a lot of discussion today about recycling. However, our project does not deal with recycling of critical raw materials, but rather raising the properties with using the critical raw materials in low amounts. So the project has been founded since a year ago. So we are in the middle of the project, and we are focusing our activities on the last year, just from the new year on. So next slide, please. So why we are interested in permanent magnets? There has been a lot of discussion today already, and people are aware of what permanent magnets are. However, maybe they're not aware of their strength. So the permanent magnets also went through a lot of history. So they have been known since 100 years, but development has made them better and better. And with regards to their strength, so at the moment, all of the world focuses on the most, let's say, powerful permanent magnets, which are based on neodymium, iron, and boron. However, not to neglect the permanent magnets, which are a little bit minor in their outcome, however, still applicable in different applications. So in this project, we are focusing on the best permanent magnets in the world, which are the most strengthful and which are used, please next slide, in the future green technologies. Everybody is well aware of that. Maybe you're not aware of the numbers. So here I just put the numbers of how many of the permanent magnets are used per electric vehicle and how many of the permanent magnets of type of neodymium, iron, boron are used in wind turbine. So just a few numbers to refresh and to broaden the horizon. We are at the moment of course, electric transition. At the moment, we have several billion cars already riding on the streets of Europe and globally. However, this segment is going to grow exponentially. And for Europe, it means a really big business opportunity with millions of new jobs created. And of course, we are in demand of several thousands of tons of these permanent magnets if you want to fulfill these requirements with regards to the market growth and with regards to the commitment that European countries has given to the Green Deal. With regards to wind power generation, here also tremendous amounts of permanent magnets are used. So we are using 0.5 ton of permanent magnets for 1 megawatt of power. And if we focus, okay, I don't want to talk about politics today. However, everybody is aware that there is an energetic crisis, there is electricity crisis, there is gas crisis. That's why we have to invest in the means which will make us independent. So what is the major problem that we are addressing with this project? There are few producers of the permanent magnets still remaining on the European floor. However, they cannot compete with the magnets which are produced in China. Next slide, please. So how we state the quality of the permanent magnets is how much of the energy they can exert out of their system. They are graded according to different properties with regards to their energy product. This is how much energy they can store and exert. And they are listed in a sort of grades. So on the left-hand side on the table, you see the grades that are present in the market. They depend on their properties, they depend on their composition, and of course on the application. What applications of the green technology need are the top-notch magnets, which means we have to fulfill some of the requirements with regards how much of the energy product they have to have. For example, the star on the right-hand side encircles the grade 15. Yeah, so these are the magnets which are used, let's say, in wind turbines or for some special application in aviation, also in the military, as I was informed. However, these kind of magnets, which are really high quality magnets, are not yet produced in Europe at all. So we are trying to help with this project and of course more globally to increase the technology innovation level of the companies still pursuing and existing in production of permanent magnets on the European floor. This is one segment. So the basic idea of how to frame the project idea came in fact from the final, no, please go back. It's not yet done, thank you. So it came initiated from the magnet users like Siemens. Siemens, everybody knows, is a big European concern. Flender is a company that makes generators, so they are also producing, consuming permanent magnets. And Valeo, who is one of the biggest European producer of the global producer of the permanent magnetic motors. It comes down to the magnet producers. Magneti Ljubljana was already presented today in one session before ours. This is a Slovenian company based in Ljubljana that produce permanent magnets. However, they are constrained with regards to achieving properties or magnets with the high grade. So the second star on the left-hand side shows where we currently are. And the focus of the project, of course, is try to lift or to boost up the properties of the magnets which are currently produced on the European floor. That's why we need a lot of support from the research and development sector, which is us, so Josef Stefan Institute. So we also coordinate the project, and we also have partners from different branches, especially from the geological side, then the, let's say, engineering side, life cycle analysis and life cost analysis, in which frame we want to somehow establish the whole ecosystem of the rare earths which are used for permanent magnets on the European floor, but really focusing on the east side of the Europe and southeast side of the Europe. So next slide, please. Okay, just click on it because there is a sort of small animation. Okay, this is my almost final slide. What we want to do with this project, yeah, we would like to boost the technology innovation level of the production line in Magneti Ljubljana, for example. For that reason, we are going to do a lot of laboratory research on the Josef Stefan Institute with regards to how to make the magnets of better properties. We are targeting both the initial composition, the processing of the permanent magnets, different levels on the processing scheme, with regards to how and in which direction the magnets are made, and trying to boost the properties up to the levels which will increase the competitiveness level of the Magneti Ljubljana. We are working in close collaboration with them, so we would the goal is to supply the guidelines for laboratory scale production. So we would like to have a sort of pilot line established on the end of the project, which would be able to produce magnets of better grades, which are produced at the moment. These magnets are going to be implemented into electric motors by Valeo. So we will try to assess their properties already in their application. However, this is not possible without a very significant support from the education side, for example. So we are having also partners covering that. So we would like to raise the awareness of the permanent magnets, rare earth supply, and the application with this regards to the younger generation and wider. And we would like, together with the partners from Sweden, doing the LCA and LCC, and of course, with the significant support from partners from Geological Survey of Ljubljana, which are networking with the partners from Serbia and Montenegro in trying to pinpoint and establish the secondary resources for the rare earths based on fly ash depots, for example, which could serve in the future for the as a source for the rare earth supply, let's say for the permanent magnet value chain in Europe and wider. So that's it from my side. I have a final slide, which is the acknowledgement to all the partners in the project, their representatives, managers, and I would also like to thank EIT Raw Materials for funding this kind of project. And I do really hope that I can inform you in 1 year time with really good results. I'm very optimistic. Thank you very much for your kind attention.
Thank you very much, Tina. Thank you very much for sharing all your good results and efforts in the field of permanent magnets. Looking forward to the results in 1 year. So now we are continuing further with a topic and moving to the alloys. So I'm inviting Blaž Leskovar from University of Ljubljana to present his work, the project Kastkuce, Innovative Quasi-Crystal Alloy. Blaž is a teaching assistant at the Faculty of Natural Sciences and Engineering, and his research focuses on complex metallics alloys, especially their synthesis and possible commercialization. Blaž, the floor is yours.
Good afternoon. Thank you for the introduction. So I will present the Kastkuce project, and which was recently founded from the EIT Raw Materials. So we are starting the project from September, and it will take 2 years. So next slide, please. It's well known that transport is responsible for more than a quarter of total greenhouse gas emission in Europe, and remains the only sector where CO2 emissions are not decreasing. So with the novel high-strength aluminum alloys, we can directly and effectively contribute to a cleaner mobility by making vehicles lighter. So our solution, in comparison to conventional high-pressure die-casting alloys, such as DIN 226 alloy, contributes to a 30% weight reduction and a 20% reduction in CO2 emissions. So because of the higher mechanical properties and lightweight design, we can actually contribute to a cleaner environment. We can reduce the energy consumption and resource utilization. Next slide, please. So the main difference in comparison to conventional aluminum alloys is that our solution uses completely different strengthening mechanisms to improve the mechanical and the chemical properties of aluminum alloys. So those mechanism is based on the metastable solidification of the aluminum-based melt to obtain high symmetry quasi-crystalline phases instead of the traditional crystalline ones. So high symmetry actually contributes to a better connection with the aluminum matrix, and that results in the higher mechanical properties. So here in the figure, you can see one example where aluminum alloy is reinforced with the quasi-crystalline phases, and potential applications for the electric vehicles, where the actually commercial parts for high pressure die casting alloys. So once again, the main difference, back please. So the main difference is that for stranding, we are using, instead of crystalline phases, use the high symmetry quasi-crystalline phases. But among this, we can also use the conventional stranding mechanisms, which is the solid solution stranding, precipitation stranding, grain size refinement, solute segregation, warp strengthening, and particle reinforcement. So we have really good combinations to address these high mechanical properties of novel alloys. Okay, now we can go further. So we are really happy that our project was selected for funding, and our results can be then evaluated by the industry. So we have Iskra, the group, which will help us to produce the high pressure die casting parts, and Collector, which is the end user, and he will evaluate the whole process, and of course all other partners which are necessary to do a project in accordance with the plan, so to really show that our novel alloys are better than existing ones. As I said, the project started in September, so we are still at the beginning. But of course, from the idea to founding, it's not the easy way. So it takes almost 15 years from the initial idea how to produce high-strength aluminum alloys with the different strengthening mechanisms to the founding. It's quite a long time. So 15 years of extensive work, a lot of research articles, a lot of bachelor thesis, master degrees, thesis, and also doctorates. And the future plans are according with the projects are, of course, first we want to patent the composition. This will be done to the end of this year. So we are now intensely working on the patent application for the composition, and then in next year we will also patent the process, and in the end of the project we'll create a startup which will then further deal with the commercialization of new alloys. Thank you very much for attention.
Thank you very much, Blaž, for presenting this really great example of cooperation between academia and industry. And now I'm inviting our third speaker. So Janez Trilobit, the founder and director of company Trilobit, will present us his case of machine vision system as a support for raw materials industry. Janez, the floor is yours.
Thank you. So I'm coming from a company called Trilobit. We are doing everything connected with computer vision. Computer vision is basically getting information out of a picture, out of a camera. Next slide, please. How we are connected to the raw materials sector is that we are developing a machine, a system for automated separation of non-ferrous metal. The problem is that companies, waste management companies, have a mix of unsorted material, which contains a lot of non-ferrous metals. And with our solution, they're able to separate these fractions of raw materials into very pure metals, which enables them to reuse them or sell them afterwards. Next slide, please. So our potential customers are waste management companies who are now transporting their waste of mixed materials to big recycling centers in Germany or in Switzerland, even more than 500 kilometers away. For that, they're using a lot of emissions or causing a lot of emissions by trucks. It is costly for them. They feel that they are being cheated there, that they're sending more material that they are getting paid for. And they also pay a lot of money for this separation service. And these are the pains that our solution is relieving them of. That means that we're reducing their transport costs, we're reducing their separational costs, and we are increasing their revenue by getting paid for more of the same materials that they are having right now. Next slide, please. This is an example. This is a prototype of one of our test machines. We're using industrial level cameras and electromagnetic sensors to detect the objects, detect the type of materials on the conveyor belt. And at the end of this belt is a high pressure pneumatic system that separates the metals physically one from another. Right now, we are still at the pilot stage. We're still testing our solution. We have given up the idea that we will be a machine producers, and rather we're trying to establish a center for high-tech recycling in Slovenia right now in Cerknica. And our next steps are the bureaucratic ones. It's a complicated procedure. It takes a lot of time, and but yeah, we're getting there slowly. This will be all from my side. Thank you.
Thank you very much, Janez, for your insights into your work. We've been following you for quite a while, and you did a lot of progress already. So congratulations on that.
Thank you.
Thank you very much, Janez, again. And we are moving to the last speaker of the session. This is Professor Sibila Borojević-Šoštarić from University of Zagreb. She is a professor in geology of ore deposits at the University of Zagreb, Faculty of Mining, Geology and Petroleum Engineering. And she will present us the RIS internship project, basically internship opportunities for master students. As it was mentioned today already several times, the capacity of students in the sector is very important. So, Sibila, the floor is yours. Sorry.
Thank you very much, Matea and Ursha, for the introduction and also for your kind invitation to this important event, UNI.MINDS. I will be talking about something completely different, and this is a competency-based project for the master students in raw material sector to be actually more ready for the market. So next slide, please. I would like firstly to show you that the background of the idea and how we progress from a small-scale project, which was ADRE internship focused on Western Balkan, focused on students and the organizations toward RIS internship. But first, I will tell you a little bit on what is in the focus, and we have a students and hosting organizations which are industry, raw materials based industry, starting from the prospection and then following up to extraction, processing, recycling, and waste management and substitution. But please click the next one. At the background, what is less visible, what are the consequences, positive consequences of the project is the increased employment of young, talented people in the raw materials industry, And something else which is very characteristic for the region in RES, Regional Innovation Scheme, is the brain drain, where the talented young and educated people are leaving due to the better working conditions in the Western and Northern countries. So the prevention of the brain drain, and also the next, the background element, which is an important one for us as a higher education institution, is to improve the educational system by connecting the industry and the university, which is one of the focuses of the raw materials EIT KICS, which Tina Benda also introduced. And then the last one, a special prerequisite for our sector in mineral resources, is that social acceptance and the perception of the raw material sector should be improved with the project. Next slide, please. So this is the pathway of the internship program development. We started with the ADRIA pilot project from the idea which was initially presented in 2017 by Hub Adria, Regional Center Adria of the EIT Raw Materials. We started with the first pilot project in 2018. We established procedures, we established the templates. We continued in 2019 and 2020, where the call was increased then in 2021 with the inclusion of Italy in the pilot. And then we applied for additional funds through the Cavacol 8 and got funded as a large project called RES Internship, which extends in the number of partners, in the number of countries involved, and of course in the number of potential accepted students and the companies. And the new project is starting, had started in January 2022, and this is an ongoing ongoing project continuing in the next 2 years. Next slide, please. Click one. So the onset of the idea was in the region which is called Adria region, which was the outreach region of the regional center Adria. And we were outreaching to a number of countries, Albania, Bosnia and Herzegovina, Croatia, Slovenia, Montenegro, North Macedonia, Serbia, and Slovenia. Quick, please. And the increase in size toward Italy happened in 2021. And then the final increase, please click one more time, happened during the RES internship project, which is actually all RES countries, including Ukraine and Turkey, colored in green. Could we go further up? So the pilot achieved, in the pilot, we had achieved 70 internships of 110 months. That included around 40 organizations. And click the last slide, please. And in the RES internship, the future plan is to include more than 350 students in more than 300 companies, to accomplish 21 matchmaking events, to train the professionals via webinars, which is more than 600 individuals, and to employ around 25 students or interns in the internship companies. More about the project is available in the project webpage. The call for students is about to close on 17th of November this year and reopened next year, 1st of February, with the new application for that would smooth the process of matchmaking with the companies. For the companies which are present here, please check the website and see whether this is a good opportunity for your company to actually search for the talented young professionals. Thank you very much.
Thank you very much, Sibila, for sharing the project on the capacity for increasing the capacity of students in the raw materials sector, in combination with all the previous presentations, which are focusing on the, let's say, innovative solutions in the either magnets, permanent magnets, in the alloys, and in the, let's say, machine vision systems. This is on top and summarizing all that also the capacity of students and professionals in the field is very important. So thanks to all speakers, you made a really nice short summary of EIT Raw Materials projects which are running in Slovenia. And now we are going ahead. We will continue with the panel discussion. So I will stop share the screen, and please all the speakers turn on your cameras that we are visible here for the discussion. Okay, I think we are all here. So starting with the first questions, and we will start with the same order as presenting, therefore starting with Tina, and questions are the same for all. How do you see your project progress? Mainly, what were the bottlenecks you encountered along the way? So Tina, please.
Okay, thank you very much for the question. Okay, project is it's a live system. I think when we put it down, of course, we make all the puzzles working in our heads. However, when we come down to implementation, it's a little bit different in some cases. I think every individual project that we are mentioning here has its own individual bottlenecks. Yeah, with us is definitely the how to get the right composition of the materials at the moment. So this is the bottleneck we are striving it, and we have not encompassed the project flow when we submitted the proposal, for example. So what I think in general, and I'm writing a lot of proposals, is somehow, or the message to the audience is that you try, when you put down a proposal, you try to, of course, you mitigate the time for the implementation, but it's really good if you leave yourself a little bit more time for implementation steps on the way when you implement. This, I think it's really important for all of the future proposals, especially in the materials section, our sector. Blaž mentioned it before. He said 10 years or 5, 12. I mean, we are developing new procedures, new materials. For that, it takes some time, even though that we are either providing new technologies or new materials, or making a progress on the technologies which are already established. If it would be so straightforward, we would not have projects like this, and we would not be talking about stuff that we talk about today. This is more general, but this is the message I would like to put forward for the first question. Thank you.
Thank you very much, Tina. Yeah, it's really a general, but it's a very important part. I think Blaž will agree. So Blaž.
Yes, definitely. So it takes actually 15 years. So
okay, sorry.
Quite a long. Yeah, but this was the first bottleneck, if you say, from the idea to get to the TRL 4-5, we need to actually to do this thing. So to do some research, to write research articles, to do some master degree thesis, to do doctorates thesis. So it actually takes time, because when you have some novelty, some innovation, if you want to succeed, to really do something new, then it takes time. So first thing for us was to change chemical composition for such a way that we can obtain the quasi-crystal phases during the conventional casting technology, so such as high pressure die casting. And because of that, you need to add some elements and evaluate the mechanical properties, the interplay between the different elements, and so on. So this was the first thing which takes a lot of time. And now when we get to the, let's say, point TRL 4, TRL 5, it's another bottleneck, how to transform these laboratory results towards the industry. So we know that in the laboratory, we have a small equipment, small samples. But when you're talking with the industry, then we are talking about tons, kilotons, not in grams. So this was then the second bottleneck, how to transform these results from the laboratory to the industrial scale. So actually, before we applied for the project, we actually did 3 trial castings and defined these critical points, and then we actually addressed these critical points also in the proposal. That's for us. Our case.
Thank you very much, Blaž. Yes, the TRL 5, 6, the value of that, as they are saying it's indeed a value of that. But it's also good that EIT can at least support partially with that transfer to the higher TRL levels.
Yes.
The same question to Janez.
Yeah, could you please repeat the question?
Of course.
How
do you see your project progress and the bottlenecks you encountered along the way?
Yeah, we have started this in 2018, and in 2 years we have put in a lot of money and a lot of hours into it. We almost sunk the company. We already had established a company. We realized that the waste management companies who are our potential customers are way different than the automotive customers where we are familiar with. And during the corona, we didn't have that many opportunities to meet these people face to face, which is very important, at least for them. They're not tech savvy. They do not use computers that much. To illustrate their point of view, one guy asked, one owner of such facility asked us if we can do this project without having a computer inside it. They do not like technology. They are still in this gray zone of doing business. So for us, it was the communication with the customers. We always, as a business, our prime focus is the customer. We develop technology after we see what's needed on the market, and we failed at the starting point. It didn't really matter that we had a working prototype. But it mattered that we couldn't talk with these people. So yeah, this would be our our downfall. We had to pause this project for almost 2 years. We have just recently restarted it after getting enough cash and some connections that are hopefully going to help us on this way.
Thank you, Janez. Thank you for sharing your entrepreneurial path, which is clearly not very straightforward and easy, like a highway, but more like a very mountain road, let's say. So thank you very much. And you also highlighted one of the crucial points is the, let's say, capacity of people we are collaborating, the knowledge capacity in a sense of getting to know new technologies. And this is clearly the thing which is this internship project addressing. So Sibila, I will give you just the floor for short overview of bottlenecks and, let's say, project progress from your side, also an importance from the capacity of students.
Thank you, Matea. Well, I would say that we could divide these bottlenecks and, let's say, challenges that we faced along the way on 2 groups. And one are, let's say, more internal that we could face is the consortia, or growing consortia. And that was actually the recognition of the fantastic opportunity that is offered by the program and supported financially by the EIT, by the industrial partners and research technological institutions, which are the hosting organizations there. and we need to put so much effort in communication or organization of actually transferring the information to every individual company, that it was extremely time consuming to us as the coordinators, but also to other partners. And you know, companies like physical meetings. They like to meet you, and then you are presenting the case, and or you use a direct email. So basically, the effort which was in making the companies to recognize the opportunity was extremely large, or we underestimated this effort at the beginning of the extension of the project. And the second part was actually more external. In raw material sector that we are targeting, majority of the companies in RES countries are SME companies. And that means that they are actually understaffed or undercapacitated for this kind of projects, because the students in the structured internship program, they need supervisors, and that is a person who will dedicate certain amount of time to the student to conduct the internship from the beginning till the end. That is our very, very first problem, which we cannot actually influence on. And then secondly, we had a lot of negative trends in the raw materials industry, which were due to the COVID crisis and due to the conflict in Ukraine. And that is heavily reflecting the raw materials industry, and they are hesitating actually to accept anything new. They are focused on the primary production maintaining on the market. And then the third thing is, what is a sad thing to be noticed, is that the international mobility is not that welcomed in the national SME, small SMEs, due to the low level of English. And that are all the challenges that we are facing to the project, trying to find different solutions for every country we join and for every industry partner that joined in.
Thank you very much, Sibylla. Lots of challenge and lots of work ahead.
Yes.
Thank you very much to all. And now,
yes, the time is running, of course, when we have interesting debates. So I would like to invite you just for a quick round of take-home messages for our audiences. Of course, regarding your experiences with EIT Raw Materials mechanisms, programs you've been working on. So let's go in the same order. Tina.
Okay, thank you very much. I mean, I think it's more than bubbling on the European floor. If you want to support the Green Deal, if you want to support the e-mobility and the green transition to the energy, we would have to have the supply of the raw materials. How we are going to do it, we still don't know yet. Definitely there are ways how to do it. I think technically is not really such a problem. I think it's more about the political will and major consortia or innovation or capacity centers and stuff like that, in order to implement this for the better mankind of the European Union. So this is how I see it. Definitely the funding, I mean, it's crucial to achieve these goals. I think what we highlighted here, it's like technical approaches, but definitely when you get out of the lab, you are facing up a lot of hurdles and a lot of obstacles, definitely, as it was already highlighted. So I think more emphasis on trying to build really good partnerships of the whole value chains, but not just from the technical point of view, but also from the, let's say, business orientation, science orientation, and stuff like that. I don't want to say the future is not bright, definitely is bright. The circumstances globally and politically, they are in fact enforcing us to speed up. So thank you very much.
Thank you, Tina. Yeah, Blaž, go ahead, please.
I'll be short. So first, never give up in something you believe. So if you think really that that can change the world, so it can even take 15 years, as you can see from our case. And you also need to find someone who can listen you from the industry. So never give up also to searching some person who will understand you and who will try to do this transformation from the laboratory to the industrial environment. That's from me. Thanks.
I would like to follow up on this. The communication with people, yeah, it's really important. It's the people who matter. The technology is just a tool. It's the people who you are doing this for. So you need to really listen to them and see what they need, and then try to do it their way, not your way. Thank you.
I will also support the statement of the last two speakers and extend it the flexibility and adjustment along the way. So one thing is gaining funding, as all of you stated, and for us, as it was an internship project, was such a need in the RES region that it was very early recognized by the EIT RM, and we got an early funding for the pilot. But along the way, when you start implementing the project, it is so important to have a flexibility and to actually adjust it all the way while the project is running. And this is the key part. They're calling it risk management, yeah, but actually it is about the adjustment and listening to the feedback of the companies, of the institutions, of the students, and actually building another version, and being more and more actually successful with the implementation.
Okay, thank you very much to all. Thank you very much again for your sharing your insights, your projects, and also the take-home messages. They are very, let's say, crucial. People matter. Be flexible and adapt in the flow of the project. That's the most important thing. And communicate to have the best results at the end, tailored to the needs of the people. So this is, we are concluding this session. If you want to have additional questions regarding the EIT Raw Materials mechanisms, we will be, me and Usha, available at the EIT Raw Materials chat. And so hopefully to see you soon next time, and have a good afternoon from our side.
Thank you.
Thank you.
Thank you.
Bye.
Thank you very much. Goodbye.
Bye-bye.
Bye.
Aha, okay. Yeah. This is much better.